So we want to determine the divergence or convergence of the following series. Now, this is not a straightforward one, but what I do notice is the 1 over n here. And I think about would happen if I were to take the derivative of this. I'd end up with 1 over this times the derivative of basically 1 over n. So what I want to do is I want to take a look at the series 1 over n, which we know diverges by p-series. I want to see what happens if I compare the two in a limit comparison test. So I'm going to do the limit as n goes to infinity. Doesn't matter which one we put on top. 1 over n over ln of 1 plus 1 over n. Now currently we have a 0 over 0 case, which qualifies us for a L'Hopital's. And that's where noticing the derivative is going to be important. So I get the limit as n goes to infinity. The derivative of 1 over n is negative 1 over n squared over, now remember we do the derivative of this separately, so it's going to be 1 over 1 plus 1 over n times the derivative of the inside. Well, the derivative of 1 is 0, so we are multiplying by the derivative of 1 over n again. So negative 1 over n squared. Here's where this becomes useful. I see that those are going to cancel. I'm just going to get a 1 on top. Now, there's a couple different approaches we can take here. We can't just flip and multiply. You would need to combine this, but that's okay. We can still do the limit as n goes to infinity, because as n goes to infinity, this piece here is going to go to 0, which makes this thing go to 1, and we end up with just 1, which is a non-zero constant. That means, by the limit comparison test, either both of these have to converge or diverge. Since we already know this is divergent, we know this guy here diverges by the limit comparison test.